It's still kind of a work in progress, but I think it's getting there. The first lecture didn't have any sound, so Danielle, can you hear me? Danielle, can you hear me? We'll find out, right? Okay. So today's stuff, same as we've been working on before. Now we can go about this several ways. But since I'm the instructor, it doesn't have to be democratic, right? I think we should do it the way the educational people say you should do this, which is how, do you think?
In groups.
In groups. And the louder and the more you're talking, the better it is, right? So that way Miriam's not sitting back there by herself. She has to move up with somebody, right? Or move across with Adrian or something, right? So let's do it in groups, and if everyone in your group is stuck, well, then you just ask. And, well, you could, yeah, right? Because let's do that.
We were supposed to staple that our homework.
To the back of the quiz.
And then what about that other sheet? I stapled the review.
If you did or not, it doesn't really matter. All I'm after is what we worked on yesterday.
So I stapled them all.
That's fine.
Is that where you're getting the ionic compound names from?
Yeah, you might want to pull it off. You might want to pull that off. That's true. Yeah.
I'll take
Yeah, you might want to, hang on to that General Chemistry Review handout.
The one quiz is going to be just only on this?
Yeah, polyatomic ions. So where's Amanda? Give that to Amanda Lozano. So go ahead and start working on these, and I'll be glad to help you.
You would happen to have a staple remover, right?
Yes.
So is it going to be only on the quiz going to be only on this, or
Yeah, just polyatomic
or
ions.
just this, right?
Polyatomic ions, yep.
This.
That's not polyatomic ions. Unless there's polyatomic ions there. Right? Like phosphate and sulfite and nitrate, oxalate. Let's get you in the stride, though, right? The educational psychologist guys that I think are on track, but let's get you in like a marathon. Let's get your stride going, right? How would you start with something like this? Oh, I like that, Danielle. Let's make everything really visual. Let's write that out. The 50 grams of what? NaOH for every 100 grams solution. Okay, how about another one? Yeah, that formula mass. 40 grams of NaOH all over a mole of NaOH. Then how about another one? Yeah, probably that 0.1 thing, right? So 0.1 mole of NaOH per liter of solution. Okay. They want to know how many grams of the 50 weight percent. Okay, so where do you see that up here somewhere? How many grams? See how many grams of the 50 weight percent? So do you see that unit up where? The first one, but we have to what? Flip it. That you don't have to start this way, but to me it's the most logical way to do this. Because right off the bat, you have what you want. Now we just keep going. Try to get rid of everything until you're just left with the grams of the solution. Right? Okay. Make sense? So the first one you could probably use is, you don't really have much choice. The 40 grams of NaOH per mole. All right, you really don't have much choice there.
You can have, like, you know, the first one you have 50 grams of NaOH, and you have 100, and you have the bottom of 100 over 50. You can have it either way.
Well, no, we want to start this way because our answer is grams of the weight percent solution. That's why we started. Here it is, right here.
You have the 100 on top.
Yeah. We flipped it because we know this is our answer. That is definitely our answer, grams of the solution. So that's why we started there. And then you just keep going and cancel until it has to sooner or later. Keep going.
At the end of its grams, you know you're going to multiply it.
Well, you have to get rid of the 50 grams of NaOH. And then you got to get rid of something else. Then you got to get rid of something else. And keep going until it's all gone, except the grams of solution. So did you get it? What did you get as an answer? 8 grams? Someone got 8. All right, so if you got 8, man, just keep going with your little group there. You are on track. You are on stride. Stride for stride. Oh, yeah. Dang, Adrian. Yeah, I get into that mode of wanting to make all this visual stuff again. But it's an MIVI equals MFVF question, isn't it? Yeah, it's a dilution. And they give you a couple M's here. A couple molarities. Yeah. Definitely. What's a typo?
Or are you looking for millimeters?
Oh, huh. Yeah, it should be milliliters, shouldn't it? It's even spelled wrong. Milla.
You knew what you were talking about.
Huh. I didn't even notice that.
Your PhD
No, they have some really interesting articles on stuff like that, where there's only a few letters correct in each word, but yet you can just read it, boom, 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 because your brain skips everything.
So I'm saying, you have a PhD in PK, I guess you are.
Everybody, that's how everybody reads.
They just keep going.
Yeah, no one looks at all the letters. It's just they skim it and they get out of it what they need. I'm going to scribble an answer down here I saw on somebody's paper. Anybody else get that? 55. 56. So it is around 56. Oh, I see a lot of 56s. Ooh, okay.
Do you care about rounding? Are you?
No, the only time you really care is when it says report your answer to the correct number of sig figs. So now we will later on when we do start worrying about, I think that's even next, sig figs. Then we're worried. Then we are worried. Now it doesn't say so.
You said they use a concentration.
Yeah, so let's see. Here's 18 molar. Diluted 2 get 1 molar. So there's your MI. There's your MF.
Oh, and it says diluted 2, and that's MF.
Yeah, 2. So to get, they kind of left out some English, but 2. Hmm?
I don't know if I did it right.
Okay, let's see. That should be 98. Oh, let's see. Yeah, that's 98 weight percent. And they want density, so they want grams of solution over mils of solution. So you're gonna end up with grams of solution. Do you have mils of solution on the bottom?
Well, I
It
just
looks
did
like
the
you do.
conversion.
Yeah, liters of solution. So that's liters of solution. That's milliliters of solution.
Okay.
That's it. You got it. The answer's 1?
I don't know. That's why I'm
Or
waiting.
the answer's 0.1.
I'm waiting to see.
Did anybody get 0.1 for B? What'd you get? 1.8? Anybody get 1.8 for B? Okay. But you got it independently?
Yeah.
Oh, I should bet that's right then. The B? Okay. Calculate the density. So I would, right off the bat on this one, I would start out with grams of solution all over mils of solution equals question mark. That's because that's what you're after, right? So then write out all those variables you have up there, like the weight percent and the write them out visually, right? And they want the density of the 98 weight percent. Let's write that out visually. And the 98 weight percent has 18 molar, so write that out visually. It should work out, right? You'd have so you could start with, I don't know, you can start with this guy and just leave him where he is. Just convert the liters to mils. But then you're going to have to mess with him, but that'd be a starting point. Or you could start here and flip him. What's that? 18, no, they said it's 98 weight percent. And look up on top. It says 98 weight percent has a concentration of 18 molar. So those are the same. And you're after density, so that's why, to me, the starting point is to write this. Grams of solution over mils of solution. Otherwise, how do you know where to go?
Because that's what density is, right?
Yep. Grams of solution over mils of solution. So I think a lot of people are getting the 1.8 for this.
No, that's the solids.
So when, do you see how to do this first one? You got to solve for VI.
Yeah, I know, but I'll
So you put a VI in there.
see. My problem right now is I can't identify what is MI,
All right.
Even though I know what
So, but the MI and the MF have to have units of big M. The V's have to have units of volume, either liters or milliliters.
have to have
They have to have big M's.
So the MI, would you say that?
That's final concentration and initial concentration.
Oh, okay.
So and they're going to be units of big M. That's why in the equation, I guess, they used M's. So here's your MI,
Okay, I got that.
and your MF is right here. And then how many mils of, where does it go? Yeah, how many mils of the reagent, so of the MI. So you're going to solve for VI, and VF has to be diluted to 1 liter. 1 liter.
Also, it's not very true on the bottom.
Yeah, but put your units in there, because it'll really help you. Put put the VI in there, put the 1 big M, put the 1 big L, because then it shows you what units VI is going to come out in.
So the algebra is easy. It's just getting the MI, VI.
But write down, don't be cheating yourself on writing units. Write down everything. Let me skip this one. All right. Does anybody around you? See if anybody around you, man, knows how to do it. And then if not, we'll start that one.
Start with the value.
Okay. Okay. So to me, this is. Does everyone see how I got the top part? If you're stuck on 34, okay. Everyone agrees with it? Okay. Now there's always more than one solution. So which solution are we after? Which one? Of what solution though? Of the 3 molar H2SO4. So isn't this our answer right there? Yeah. That's where I would. I mean, you don't have to start there, but it just might as well be logical. That's how we did in the past, the ones before this. So that's where I would start. And a liter. You don't have to start here. And in fact, we might as well get it into milliliters right away. Otherwise, we're going to forget. Because don't they want it in milliliters? Okay. Now what could you do? Yeah, you're right. Pedro's right. But what I'd like to do is not skip anything. Instead, write. See, this is mole H2SO4. 1 mole of H2SO4. 1 mole of. I can't jump that high. The sulfate, right? Because then you're not skipping anything. And if you're trying to explain it to somebody, man, they can see exactly what you did. So all of this is going. This ratio is just from the formula of H2SO4. It's a 1-to-1 ratio, right? If this would have been H plus down here, it would have been 2 of them, because we're just looking at the formula of this. That way, people can see where you're going to get that reaction from. Okay. Now we're ready for what Pedro said.
And then it's still 1.
Yeah, it's all 1-to-1. But to me, it looks nicer. It's easier to see what the heck is going on. Okay, now what though? This guy? This guy? Yeah, I would too. I'd do 1 mole of Ba for every 1 mole of BaNO3 too. And that would help you catch something here. We want to we're just really keep going until you get everything to cancel out on you somehow. 1 mole of Ba, One more. This is from the formula again. Barium nitrate. Okay. Now what are we ready for? But you see a problem though? The moles, here, let's start canceling stuff so you can see what the problem is. Liters. You need something to cancel with this mole of barium nitrate. The molar mass. That's why you can't use this right away, because this isn't going to cancel on you. So use molar mass. Good. I'm going to go further over. You need a barium, a couple nitrates, and 6 oxygens. Sorry, a couple nitrogens and 6 oxygens.
261.
I hear 260. Anyone else get 261? Kat, you got two? Okay. 261 grams of barium nitrate. Okay. Now see it's nice and clean. Now I do that guy. Okay. Now isn't this kind of weird though? That's right. But what's kind of odd about it? One solid, one solution. The only place where we messed up is we didn't. You got to read the question really kind of carefully. We like to think of percents and concentrations always to be a solution. It doesn't have to be. You can have salt, table salt, for example, has, I forget the name of it, but it gets all clumpy if you don't have it in there. So you describe the concentration of it. You can use molarity. You can use weight percent or whatever that funky thing is in salt, but it's not a solution. It's a solid. So we shouldn't have wrote grams of solution here. We should have wrote 100 grams of solid, because that's what it is. It's not a solution. It's a solid. And then you got what? 1.2? 1.29. So everything on top, multiply, bottom divide, order doesn't matter. And what we did to start out, we just started listing out everything in the question in a very visual manner. Oh, everything canceled but milliliters. Go through all that work and I write grams. Thank you. Milliliters of that 3 molar H2SO4 solution. So that's probably what we should write. Is you should write the whole thing. 1.29 mils of the 3 molar H2SO4 solution. But so again, starting out, just try to make stuff as visual as you can, and then try to find what you're looking for, and thereafter mils of that solution. So that's why we started out where we did, and we flipped it. Okay.
Well, you're using the equation, right, for the SO4, sulfate, right?
Here.
Since the
Yeah, I'm using the chemical formula.
Since the stoichiometry is all 1 to 1 to 1.
Yeah, I'm using the stoichiometry, exactly.
If it was different, then the math would be different, then, right?
Oh yeah, if there were 2 sulfates in H2SO4, there'd be a 2 down there.
You have to divide by 2.
Yep, you have to have a 2 down there, but it isn't. That way it's kind of nice because you don't screw up if the formula isn't 1 to 1, because not everything's 1 to 1.
So stoichiometry does matter, then, right? That's a long conversion.
That's a long problem. What I like about it is if you start out in a logical place, you can just blindly keep going until everything disappears. That's what's kind of nice about it. You really don't have to see where you're going. Just have faith that everything's going to cancel out at some point. Everything's going to cancel out at some point. That's the molar mass of barium nitrate. Somebody told me that. Oh, you guys want these back? What is this? Randy, you might want that for Wednesday.
Oh, well, I have my sheet that Dr. Mukia gave us.
Okay. Otherwise, it's just thrown up. I don't know what to do with it.
Okay, well, do you want me to hold on to it?
Yeah, hold on to it. 'Cause it's not on. It's not attached to your quiz. Okay. How about 21? Anybody get an answer for 21? Stuck on 21? Okay. Find the molality. So what is molality? Write that out somewhere. Otherwise, you don't even know what you're going after. What is molality?
That's the
It's moles of what? Yeah, moles of solute all over kilograms of solvent. But we got to be more specific here. Moles of Ki all over what? Kilograms of, not solution, it was the solvent. So what is the solvent? You got to know what it is. So the hint is aqueous, H2O.
We say this fat's always going to be water, right?
Oh, if it says aqueous, yeah. Solubility is always aqueous. Okay, let's start writing some other stuff down. 28% Ki. What else do we have? Density. What else? So that's it, right? Okay. Yeah, if we need it. Okay. Moles of Ki over kilograms of water. I guess, where could you start?
I started with 100
Well, if you start by flipping the first there is no kilograms of water in here at all. We probably need to, before we figure out where to start, we should probably get that one in there. Okay. If something with water in it, take a look at this one. What is in this 28% Ki? You have 20 grams of Ki for every 100 grams of solution. Well, what's everything else then? Water. So we can write another conversion factor. What would it be? 80 grams of H2O for every 100 grams of solution. That, to me, is the trick to this question, right? Because all that's there is Ki and water. So if you have 20 grams of Ki, you have to have 80 grams of water. So now, it'd be a lot easier to see where to start. Now where would you start? Now, oh, sorry. I don't know if you realize I was talking to somebody. This is what we're after. Right? That's what we're after. So find something. We could. Yeah, but I don't see any moles of Ki anywhere in here. We might need it. I'm looking for a starting point. Start with the 80 grams of water thing. Why? Because you can flip it. You have the kilograms of water. So like when you start mentioning, do molar mass, I don't know if you need it or not. Right? Why do extra work? Just find a starting point. I agree with Kat. But we need to what? Flip it. So we're going to do the, I didn't flip it. 100 grams of solution. You have 80 grams of water. So we might as well just convert that into kilograms right away. Otherwise you might forget. So how many grams in a kilogram? 1,000. Now see how it's helpful. Write the kilograms of water. Write the grams of water. Because that's your whole guiding point of all this. If you don't write it, the problem's not visual and you're shooting yourself in the foot. Okay, so we have the grams of water's gone. The bottom's done. Now you probably see what to do. All right? Yeah, I would do that one. The 20 grams of Ki over 100 grams of solution. And keep it that way. Otherwise the grams of solution won't cancel. Then you got to get rid of the grams of Ki. Where is our density? Let's just write it in here. I don't see where we're going here. 100 grams of solution. Oh, maybe we could just use the... You want moles of Ki? Yeah, let's write that in. We said 100 grams of solution. No, this is where those dudes who can play chess and do like 50 steps in advance of these... I can't even do 2 steps in advance of this. Okay, what were they doing? 20 grams of Ki. Okay, now someone's talking about molar mass. I bet you that, right? Because then, get rid of the grams of Ki, get it into moles of Ki, and then you'd have moles of Ki over kilograms of water. We never even needed which one? Density. Maybe there's a solution that involves the density. I don't know. I bet there is. But yeah, just do molar mass and we're done. It's 166? Yeah. Oh, thank you, sir. Grams of Ki and a mole of Ki. So now everything cancels, but the moles of Ki all over the kilograms of water. That should work. So that's starting, I think the 2 keys were this and this, right? Writing down the visual definition of molality and then realizing, geez, we don't have kilograms of water anywhere. So you have to make one. You had to make that conversion factor because otherwise it wouldn't work.
Does anybody else do 1.5?
Yes.
1.5, I hear. Okay. And looking at the next one, for the first part, I don't think you need the new conversion factor. But in the second one, I bet you do. Right? How many grams of water? I would do the first part first, but I bet in the second part you have to make that conversion factor, make your own like we did in 1-21. Because it said aqueous. It's aqueous again. Yeah. So you can write the same type of equation. We usually write 70.5 grams of perchloric acid per 100 grams solution. Or what's 100 minus 70.5? 29.5? So it'd be 29.5 grams of water per 100 grams of solution. That's probably how you can do the bottom one. The first one, yeah, you don't need to do anything fancy. It says it right on here, HClO4. So the first part isn't so bad, right? Just one step. I mean, you're not used to something that easy. You see that? You can start by, they want to know grams of HClO4, so leave him alone. Just get rid of this. Oh, it's right here. Just multiply it by that. Did you see that? They want to know how many, oh, what do they want to know? Sorry. How many grams of HClO4? Oh, they want to know this. Oh, that is right. Right? So just leave him alone. Multiply these two together. It's almost set up that way. Multiply this times that, boom, boom. You end up in grams of HClO4. So start out with and then we'll have it. And then you have a part B. There's a couple ways to figure out part B, but what is the answer right here? 26, what is it? 26.5. Okay, now Kat, say what you're saying. Yeah. Uh-huh. You'd have the grams of the water. Everything else. That's one way to do it. The other way is what? Multiply this 37.6 times, make a new conversion factor with a weight percent of water, and you get the same answer. Okay. That's one way. Or let's see, 29.5. Both of those ways should work. So have a good 3-day weekend. Oh, because you take 70, it's actually 70.5 grams of HClO4 and 100 grams of solution. That means 100 minus 70.5 has to be the grams of water. And that's going to be 29 and a half. Whoops, sorry. Okay, thank you. Have a good weekend.
You too.